I'm back with another video, and this time it is in immutability. So immutability in Java is the topic. So what immutability is a property where an object state cannot be modified after it is created. So what does it mean by an object's state? So object's state meaning like the variables which is inside the object that cannot be changed. Like, say for example, if you have a primitive type variable like integer, but like int, or a wrapper class integer, or a list of integers, all those will not be modified. In case of list, there cannot be any new element added or removed. So this is what state cannot be changed means, cannot be modified. So let's start with what exactly immutability is and how we can achieve it. So in Java, immutability objects have all their fields declared as final and private. So the class will also be marked as final. The variables will be marked as final and private, and there will be no setter methods. So if we see in this class, we have a getter rank, but we have a getter id, but we don't have a setter here. Any attempt to modify the certain immutable collections like those returned by this will throw an unsupported exception at runtime. So basically what immutability is like, say we have an object created in Java. So by any means, that object cannot the object's variables or the object's variables cannot be changed. Like, once the object is created, it is treated as a read-only object. So read-only object only, and if you try to modify any variables in or any value of the variables inside the immutable class, we will get an exception which says unsupported operation exception. This is by default with in case of collections, but if you want to handle any modifications, then we can throw it by using custom logic. So there are some advantages of immutability in Java basically. So the first one and the most important one is thread safety. So since once an object is created and it is in a read-only mode in by any means, so any thread will be, if multiple threads will be trying to access the object variables or object, they will get a constant value of that particular variable. So like, if say int a equals to 5, so all the threads going to access it will be getting value 5 only. So this is an advantage. And like, here we don't have to deal with the synchronization overheads where we have to like add synchronization blocks or maintain thread communication lifecycle and all that. So all that overhead is removed in this case. Then we coming to a consistency of state during its lifetime. So consistency of state, like, as I said, if a collection is there, that collection will be fixed. Like, there will be no addition, no subtraction of elements from the collection, and we cannot update the position of the collection as well. So this feature of immutability is what consistency means. And like, from since the time the object is created till the object is destroyed, maybe by the garbage collector or whatever, so during that period the object will be consistent throughout. Then we have enable caches and reuse of objects. So this is an interesting point. Like, just like we have integer caching, like integer caches values from -127 to -128 to 127. Similarly, we can cache these immutable objects so that it's easier for it doesn't have any overheads in the application, and the execution is faster. Then we have all right. So then we have facilitates use as keys in maps and other collections. So basically what happens is that like, I'll give an example. Like, we use strings in most of the keys in map and other other key value collections. So what happens is that string is also immutable. So basically we add a value to a map, say with a key as say like ant, and we put a corresponding value in the map. And now if that ant is stored in a string variable, and if you try to modify that, then we will have another object, another variable in the string, and that original variable ant will be preserved. So that value is there in the map, but that is not available to us. But if we somehow manage to get the key name, then we can get the value from the map itself. So because of immutability, the original map, original value is not being hampered. So this is how we can use a string. This is why generally we use string in maps, but if you want to have a custom object as a key, then that immutability is perfectly suited for this particular type of operations. Then we have certain types of like we have certain categories where immutability is achieved. So for first one is variables, then second one is wrapper classes, third one is collections, then we have custom objects. So the first one is variables. So like variables meaning primitive variables, like primitive variables, short, byte, int, long, float, they don't by default they are not by default immutable. To make them immutable, we have to add a final uh, final final keyword in front of it. With this x equals to 10 is immutable. So now if we modify the value of x, we will get a compile time error because x is final, correct? So if we so to be clear, primitive data types are not immutable by default. We have to make it immutable by adding a final keyword in front of it. Okay, then coming to wrapper classes, the good thing is that all wrapper classes are designed to be immutable, which makes them thread safe to use in concurrent environments and allow for various JVM operations. So wrapper classes, like as I like integer, string, not string, integer, then big integer and all that. So wrapper classes are by default immutable. So like see like we will be discussing more on that, because since it is immutable, so we can use it in our system, in our applications multiple times, and that is also good practice to use them. Then we coming to collections. So collections, by default they are not mutable, but if we do it like this, like if we wrap it around collection.unmodifiable list for array list, linked list, or list.off. So basically list.off returns a immutable collection of data. So if we like say for example, if we do something like this, list dot off, say for example 3 comma 5 comma 6, then okay, so it says that this can be removed. Okay, the result is ignored. List of, let's say integer, correct? So now if I do something like data dot add, it will give an exception. See, this is giving an exception. It is saying that it can be an exception. It says unsupported operation exception, because this list.off is returns immutable set of immutable collection. Basically it returns immutable collection, correct? So and we have another way of doing it in Java, is that collections.unmodifiable list. So any data, any collection which we initialize, if we wrap it around unmodifiable list, then that will be treated as a immutable collection. Or if we create a static list, then we can do list.off, that will be treated as an immutable collection, correct? Now in case of arrays, we have to use an approach which is called defensive copies. Defensive copies is basically copy of a mutable object instead of sharing references. So basically what happens is that in case of collections or objects, we don't actually keep the object itself, we just keep the reference of the object. So what happens is that reference can be accessed by some other object as well. So here we are claiming that to be mutable, but some other class will try to change, some other object will try to change it, and the value will be changed internally, and it will be reflecting in the immutable class as well. So to handle that, we have something called defensive copy. So defensive copy is creating a copy of mutable object instead of sharing references. So here you can see we have an like say we have an immutable class, okay, and this is having a, okay, this is a, okay, let's go here, let's stick to here only. So this is the immutable person class. So here we will have we will have so we have this list, and if like we are assigning a new object, or a new collection, and then adding that original collection to the constructor. So with this, every time when an object is created of this immutable class, this list will be a new list. So new list meaning like it is like it may have the modified data, but it will be a new one for this particular class. So anyway the immutability is achieved in in this case. But now let's move to the second part. Like now we have the getter. So in getter also we have something like uh, we have to wrap it around this unmodifiable list. So what will happen is that once so now this hobbies will be again wrapped inside this unmodifiable list, so that whenever we do something like get hobbies, we don't perform this sort of operations, like as like here I can say like get id then dot set or dot add. So these are violating the immutability feature. So you can see we are getting this exception warning over here. So that's why we are returning this as a unmodifiable list, so that this array is not modified either way. So true mutability is achieved. Now coming to custom objects with immutable class or collection as variables. No need to do anything over here. So like we have a custom object which is immutable, and then we have a collection which is also immutable. So in that case we have to do we don't need to do anything. That is immutable by nature. So now we have another subset of this is called custom object which is immutable with mutable class or collection as variable. So if it has a mutable class or collection, so say we have a person class which is immutable, and there is a address class which is mutable. So it has mutable variables. So what we can do is that in this mutable class we can have a we can have a constructor which takes this particular uh, which takes this particular object as a parameter, and then whatever functionality this address class is having, that can hold it there. So what will happen is that when we try to create an instance of address inside a person class, or rather when we try to create an instance of the person class, what we will be doing is that we take the address. Okay, so this is not the example. So we will take the address. I'll put it in this way, like say person so what will happen is that say something like this dot address equals to new address. Sorry. So with this what will happen is that address might be mutable, but this address, this field, this dot address is immutable. So we are assigning a new object to this. So this will be treated as as immutable variable of this class, correct? So this is an example of deep copy in case of a custom object, and this is an example where, okay, so this is an example of deep copy soft where is that defensive copy rather. This is an example of defensive copy for objects. And then now coming to collection as variables. So custom object with a collection of mutable objects. So here we can see we have person, and then we have a list of addresses as mutable class. So we will do a deep copy of address list and their contents as well. So in this case, what will happen is that the address, we have a list of address. So what we will do, we will iterate over the each object of the address, and then make them as mutable by adding a new instance of that, and then adding this to the unmodifiable list. So with this, we are doing a deep copy of a custom collection object. Okay. So these were the practices which we use to achieve immutability for objects and variables. And if you the use cases basically be is we can, as I said, we can have uh, thread safety, consistency, caching, that can be used as keys in maps. So these are the use cases, and this is quite a frequent question in interviews as well. So I hope this will be helpful for you, for you all. And thank you. I'll come up with another video next time. I'm back with another video, and this time it is in immutability. So immutability in Java is the topic. So what immutability is a property where an object state cannot be modified after it is created. So what does it mean by an object's state? So object's state meaning like the variables which is inside the object that cannot be changed. Like, say for example, if you have a primitive type variable like integer, but like int,